Imagine you are driving a car. With a manual transmission, it is difficult to control speed and power. You have to adjust both the gas pedal and the gears to get the right balance. Now imagine if your car had an intelligent system that automatically adjusted everything to give you smooth acceleration, precise speed control, and efficient power usage. That's exactly what vector control, field-oriented control, FOC, does for AC motors in industrial applications. The reasons for preferring a DC motor in those days were that a DC motor directly allowed power changes, which facilitated precise speed and torque control, and it satisfied the application quite well. This is because it has brushes and commutators, and hence requires regular maintenance. Here is how vector control works. At its core, vector control is an advanced algorithm used in VFDs that allows an AC motor to behave just like a DC motor, offering smooth, precise control over speed and torque. Here's how it achieves that. Real-time monitoring. The system continuously measures key motor parameters, such as current, voltage, and rotor position. It gives live feedback, allowing the immediate making of adjustments. Mathematical transformation. AC motors work off alternating current. The current is constantly changing direction, so vector control transforms these AC parameters into an equivalent DC-like format using very complex mathematical models called Clark and Park transformations. The motor can thus be controlled relatively easily as though it were just a simple DC motor. Decoupling torque and flux. In a DC motor, you can separately control torque and flux. In a conventional AC motor, they are locked together, and you cannot decouple them independently. Vector control decouples them, so that each can be set to an arbitrary value, similar to in a DC motor. Accurate voltage and frequency control. Finally, the VFD sends pulse width modulation to deliver the precise voltage and frequency needed to the motor. This means that the motor operates with minimal waste of energy and smoothly. Why it matters. Now, with vector control, AC motors can replace DC motors in applications that require high precision, fast response, and efficient operation, all without the hassle of maintaining DC motors. Thus, thanks to vector control, AC motors can do everything DC motors could do, but better, longer, and with less maintenance. And